China now operates more ships than the United States Navy. By hull count, it is the largest fleet on Earth. That comparison gets repeated constantly, and it sounds decisive. But there is a problem with that metric, because naval power is not measured near the coastline. It is measured at distance. And past roughly 1,000 miles from shore, the equation changes. 1,000 miles. The distance from Shanghai to Guam, from Hainan Island to the Mariana Trench. It is where the Western Pacific stops being a near sea and becomes open ocean. At that range, fuel logistics multiply, maintenance cycles compress, replenishment becomes exposure, and fleets built for regional control begin operating under constraints they were not optimized to solve. The question is not how many ships China has. It is whether those ships can sustain full combat output once they move beyond their support base. At around 1,000 miles, that answer begins to shift. And that is where the comparison between China's Navy and the US Navy stops being about numbers and starts being about design. Understanding why means looking at what actually fails first. Before combat even begins, distance starts compounding cost. Every mile a fleet moves away from shore support stretches its logistics chain. Spare parts must travel farther. Replacement crews rotate slower. Medical evacuation times increase. Intelligence cycles lengthen. Distance reduces margin. A fleet operating 200 miles from port can absorb mistakes. A fleet operating 1,000 miles from port cannot. Small inefficiencies accumulate. Minor mechanical issues stack. Refueling windows become scheduling constraints instead of conveniences. Distance does not degrade capability all at once. It erodes it gradually. And that erosion begins long before the first missile is fired. When a conventionally powered surface fleet operates far from shore, the first constraint is not combat. It is fuel. Fuel is mechanical. It does not respond to strategy. A diesel or gas turbine warship burns through fuel in days. Under sustained operations, consumption rises sharply. That means constant replenishment. Tankers must meet the fleet every few days just to maintain position. Those tankers are slow and lightly protected. Every replenishment operation forces a pause. The fleet slows, hoses connect, defensive posture thins. Multiply that across an entire task force and the logistics chain grows outward. You are no longer projecting ships. You are projecting a fuel distribution network into contested space. And that network becomes a vulnerability of its own. Fuel logistics do not just constrain operations. They create structural exposure. Consider the math. If a destroyer consumes 15 to 20 tons of fuel per day at cruise, and significantly more under sustained operations, then a 4-ship surface group requires dozens of tons every 24 hours. An oiler carries thousands of tons of fuel, but that fuel must be distributed at sea, ship by ship, hose by hose. Now scale that to an entire carrier strike group. Multiple surface escorts, amphibious ships, support vessels, each with different burn rates, different refueling intervals, each requiring scheduling, protection, and precise coordination. The logistics timeline becomes as complex as the operational plan itself. And unlike weapons, fuel cannot be rationed indefinitely. When fuel runs low, ships slow down. When ships slow down, tempo drops. When tempo drops, initiative shifts. And fuel is not the only system that degrades. Maintenance follows the same pattern. Gas turbines require servicing. Electronics overheat. Saltwater corrodes everything. Most maintenance planning assumes port access. At distance, repairs become reactive. Inventories thin. Timelines stretch. Ships rotate back not from battle damage, but from mechanical wear. By 1,000 miles, a conventionally powered fleet is no longer operating at full strength. It is managing constraints. There are only two solutions: shorten the distance, or remove fuel from the propulsion equation. The US Navy chose the second. Nuclear propulsion removes propulsion fuel from long-range operations. A nuclear-powered carrier does not refuel at sea for propulsion. It generates its own energy for decades. It maintains speed and posture without tanker dependency. That shifts the structure of the entire task force. A conventional carrier group requires multiple oilers. Those oilers require escorts. Those escorts require fuel. The logistics chain compounds. A nuclear carrier group still requires aviation fuel, food, and munitions. But propulsion no longer dictates tempo. At 1,000 miles, a conventional fleet manages fuel. A nuclear fleet manages missions. Naval power is not measured in ships present, it is measured in missions sustained. A U.S. carrier can generate sustained daily sorties for weeks without returning to port. To understand why this matters, consider duration. 100 sorties in a single day is impressive. 100 sorties per day for 3 consecutive weeks is decisive. Sustained air operations allow continuous surveillance, repeated strike windows, and persistent defensive coverage. A fleet that must interrupt operations every few days for replenishment cannot maintain that rhythm. Even short pauses compound. Aircraft maintenance cycles shift, flight decks reset, escort positioning changes, and in naval operations, tempo is leverage. The fleet that sustains operational tempo shapes the engagement. The fleet that pauses reacts. Energy independence supports launch systems, deck operations, and onboard maintenance without competing with propulsion demands. Aircraft cycle faster, repairs occur on board, tempo holds. Now contrast that with a fleet constrained by refueling cycles. When replenishment interrupts movement, sortie windows narrow. When escorts rotate for maintenance, coverage thins. When parts run low, readiness declines. Sustained presence at distance requires sustained output, and sustained output requires energy systems and logistics networks that do not degrade under pressure. At 1,000 miles, a single U.S. carrier strike group can sustain more weekly sorties than a larger conventional fleet constrained by refueling and port rotation. That is not firepower, it is endurance. And endurance defines blue water power. China's Navy is modern and capable. Within the first island chain, it is optimized for regional dominance. But distance imposes costs: fuel logistics, maintenance strain, replenishment exposure, output decay. These costs compound the farther a fleet operates from shore. Around 1,000 miles, those costs become structural limits. A conventional fleet can push beyond them, but capability declines as exposure rises. Nuclear propulsion removes one of the largest structural constraints. That difference reflects design priorities. One navy was built for regional reach. The other was built for sustained global operations. The 1,000-mile threshold is where that difference becomes visible. It does not determine who wins the first exchange. It determines who is still operating after the first month.